going to do a single stock today. BrIstol Myers, one of my old favorites. One of the first companies I ever looked at, actually. The way I look at drug companies and what's really nice about them compared to other kinds of companies is that you basically just have to look at each drug. There's not actually a lot more to most of these companies than just looking at every single drug. If you look at every drug, you basically will get a sense for the value by just looking at the portfolio. There isn't a whole lot more to it than that. Management skill is very important, but ultimately the most important thing is what are the drugs worth? Where are they going? Things like that. So we're just here to talk about one stock. I'm going to make this video and save it so you guys know how to look at a drug company in really in-depth detail. BrIstol Myers in the late 90s, I think a lot of big pharma, that was like the big pharma heyday. There was also a drug they had called 𝗟𝗩𝗘𝗢 that a lot of people were excited about. People thought it'd be like a cancer cure. It didn't end up being a cancer cure. Really amazing company, like I said, responsible for a lot of breakthroughs over the decades. But the funny thing about the drug business is you have to constantly reinvent yourself because your drugs go generic. And that makes it very hard to build a business for the long run that actually has brands and things like that. It's rather just, frustrating building a drug company because there's a life cycle to every drug. And that life cycle means that all of these drugs will one day sort of come and go. And when we look at the model, which you can just sort of put together through the 10Q, their biggest drug right now is called Eliquis. It's a blood thinner, sometimes called Apixaban. And Apixaban is a great drug, but it's going to go generic soon. And that means that there'll be no profit left once it goes generic. Opdivo is a great cancer drug, but again, at some point there'll be a biosimilar. Pills go generic, and when a pill is generic, it means that any company can make it and make it for rock bottom prices. Generally, pharma companies lose 90, 95, maybe even 99% of their revenue from that drug when the generic drugs hit. In biological drugs, which are not pills, but they're antibodies, and they look very different. In fact, let's take a look at exactly what I'm talking about. I'm going to show you the molecular structure of Apixaban. And here it is. Pyrazallopyridine. You can see its physiochemical properties. This is a website called PubChem. Not a lot of people use PubChem, but it's kind of cool. And like I said, it's used for blood thinner. It sort of was a better warfarin. Pyrazallopyridine. So there's the pyrazole and the pyridines here. This is a heterocyclic ring. And BrIstol Myers did this drug, I want to say by themselves, or no, they do it with Pfizer. They sell it with Pfizer. And I think it was a Bristol drug invented and then Pfizer sold. So anyway, this drug is very easy to make. In fact, you can give this to a chemist, and a good chemist can say, okay, I can make this in 4 synthetic steps, or whatever it is, and I need a pyridine, I need a carboxamide, I might need a piperidine, and I'm going to do these substitution reactions, and eventually I'm going to get this drug. And with a really good chemist, you want to minimize those steps, but the point is it's going to be really cheap and anyone can sell it. You have to spend about $2 million to be able to sell it. You have to do a human study that shows that the blood levels of your Apixaban is the same as the blood levels of the real Apixaban. But once you satisfy that, you're basically good to go. And you even have things like, here's the mass spec trace. It's very easy to see the peak levels there. It really isn't hard. You even have vendors here where you can buy the raw material and then do your own trial and see if you can get Apixaban sold. And you might make money, and that's how small drug companies generally start. They start making generics. But Apixaban will go generic, and it will no longer really be a BrIstol Myers drug. The revenue will drop from several billion a quarter, which is enormous, to some very low number, maybe 10 or 20 or 30 million a quarter. That's just something to keep in mind. And timing for that patent cliff is what we usually call them, is something we have to think about and look at very carefully. Drugs like Opdivo, this is a drug called 𝗔𝗡𝗎𝗓. If I wanted to show you the chemical structure, it's going to look very, very, very different. And the reason is it's a very large molecule. This is kind of what it looks like. This massive, massive molecule. So if you were to think about the drug I just showed you, Apixaban, fitting in 𝗔𝗡𝗎𝗓, it might be just right here, just this little tiny piece. So by comparison, it really is a gigantic amount of molecules, and there's no way to fully And this is just the Fab fragment. The entire molecule is even bigger. I was wondering, is this a single chain? I didn't think it was a single chain. But the Fab fragment is just one piece of it. The entire antibody looks like this. And you can see the Fab fragment here. But there's also this constant. This is FC is fragment constant. And this constant region is very large as well. So you basically have this huge, humongous drug, maybe 100 times bigger than a small molecule. And there's no real way to do mass spec on that and understand that it's exactly the same. So what we have is something that's evolved for 25 years called the biosimilar framework. And biosimilars are a lot like generics, so they also will tank your sales. Here's another drug from BrIstol Myers called Revlimid. And this used to be one of the biggest drugs in the world when it was part of a company called Celgene, a very legendary biotech company that merged with BrIstol Myers. And Celgene's drug, Revlimid, is going off patent. And so revenue is declining very rapidly for Revlimid. But it's a very unique drug, so it's not going to fall off a cliff the same way I described earlier. Pomalyst is a lot like Revlimid. It's almost the same drug, in fact. I can show you the structures differ by very little. Yervoy is an antibody, so it has a bit of a different expiry profile. So I'm just ordering these by revenue because at the end of the day, what are we trying to do here? We're trying to analyze every single medicine and understand where's the revenue and earnings for BrIstol Myers going to come from. Well, we might as well start with the biggest drugs and work our way down. And then we can also start with the pipeline, which are drugs that are not yet approved, but will be, and see if any of those are going to be big sellers. So Reblozyl is a really interesting drug, sotatercept, that, is it sotatercept? Do I have that right? I don't think it's sotatercept, actually. It's from the same company that makes sotatercept, but it's luspatercept. And luspatercept is a really interesting fusion protein. And it's a new drug, so it's very unlikely to go generic anytime soon. It's probably going to be one of Bristol's biggest drugs in the long run. And it was from a company that I used to own some shares of called Acceleron, which was an amazing company. And Acceleron was bought out by Merck for sotatercept, their other drug. They should have stayed independent. I think they would have done better for everyone. It was going to be a monster company. They could have sold all the medicine themselves. They didn't even need Bristol or Merck, but it's not always easy staying independent. All right, so there's a bunch of other exciting drugs from BrIstol Myers. Like a lot of drug companies, they're facing expiry for their bigger drugs, and then eventually the smaller drugs are going to try to kind of compensate for that. But every drug has its life cycle. It's kind of like the circle of life. You really just have to understand that when you're investing in these companies or trying to understand these companies. All right, so let's start with Eliquis. We have the quarterly sales. Let's actually go to 𝗥𝗢𝗢𝗓, which is a rival to Bloomberg and will hopefully be better and cheaper than Bloomberg over time. We'll open up the latest 10Q, which the SEC website has kind of gotten, so I'm really happy 𝗥𝗢𝗢𝗢 lets me pull up company filings really quickly, because that's one of the biggest jobs of a financial analyst. And Eliquis, yeah, 3416. So it's a really, really big drug, right? 3.4 billion a quarter. And in fact, I have another spreadsheet I want you to see. I'm going to put down kind of experience of BrIstol Myers, because it's really interesting how big Eliquis got, just so you get a sense for how big these medicines kind of get. Just so you get a sense for like the biggest drugs in the world, like Keytruda. Keytruda's selling several billion a quarter. I just was wondering if I had this in annual form, because looking at it in quarterly form is a little tedious. And so this is basically a database of the largest drugs in the world by quarter. And the Eli Lilly drug, which is their version of Ozempic, is basically on track to be the biggest drug ever by far, and even double what Ozempic ended up becoming. So I'm basically stacking the quarters by their first quarter. So in the long run, some of these drugs started out slow and then ended up really big. But I also want to do it for annual, just because that's almost like a more meaningful metric in some ways. So maybe I should do that. Ozempic, 3.7 billion in the full third year is a lot. You can see that the whole point of this, showing you this, is that Eliquis is a big drug. It's doing 10, 12, 13 billion a year. All right, so we're looking for the 2017 revenue for Eliquis. Why are we doing this? It's good to be complete. You know, you don't want to not know your stuff. Even though Eliquis is probably going to go generic, it doesn't take long to pop the numbers in. So you can see how sharp the revenue increase was. I think they were approved in 2014, but we should have that data somewhere here as well. And like I said, Eliquis is just a blood thinner. There it is, 7913 FDA approval. And I'm going to note that in the model, 7913 FDA approval. And here's Eliquis. And it's Pfizer and BrIstol. So I want to make sure that we're actually getting the whole thing, because I'm not sure if Pfizer books revenue for Eliquis as well. So I'm going to just sort. This is a very partial list of drugs, by the way, in the drug industry. But it's going to become a full list if I keep adding to it, right? So let's sort by, what is this, column A, B, C, D, F, G. So Eliquis, at least on this partial list, is had the fourth biggest year 3. So I just, again, want to get you a sense for just how massive these drugs are. Eliquis would actually be the 3rd biggest according to the year 5 launch. So right now, it's, like I said, it's in the 12-13 billion range. So when will this massive win kind of disappear? And we're going to look at the patents and see, like, eventually this revenue trajectory, you know, you can see that the revenues kind of slowed down. It went from a small number to 2 billion, 3 billion, 5, 6, 8, 9, 11, 12, 12. It's sort of slowing down. 12.5 will be this year. And then it's going to go off a cliff. And I have this cliff starting probably way too late. I think the cliff will come sooner. And in fact, you can see in this old filing that they estimated that it would be 2026 when this drug would go generic. So if that were true, this model is way off. And I would even have it maybe something like this, where it drops from 13 billion to 2 or 3 billion, and then it drops to 500 million. So very rapid sort of decline we'll see here. Now, I think they may have gotten a new patent or something like this, so we just have to look at that really carefully. Back then, BrIstol Myers had a bit of a different portfolio where you can see 𝗟𝗡𝗡𝗢 was a big drug for them. 𝗟𝗡𝗡𝗢 is long gone generic and is no longer a big medicine for them. But at the time, it was one of the leading drugs for hepatitis B. Sustiva was also a major medicine for them, and that was one of the best HIV drugs. And it would often be paired with different HIV drugs to create great combination drugs. 𝗟𝗡𝗚𝗓 was another HIV drug. So they had a decent HIV portfolio there. But that portfolio has all gone generic, hence what I'm talking about, which is very frustrating. As a drug company, you spend all this time, do all this research, you make these beautiful drugs that save people's lives, and then the patent monster kind of runs out and it's over, which is kind of just really wild if you think about it. But that's the business, and you have to play by the rules of the business. Having biosimilars or biologics gives you a little bit better of an opportunity to evade the generic monster. I think probably a little inadvertent at the time when drug companies realized that you could really do well by just having biologics instead of generics. It's kind of a really nice thing to realize. Biologics instead of small molecules, I should say. So anyway, let me get one more year of old revenue. Just a completist. I'd like to make sure that I have everything. It'll only take 1 minute. Okay, and you can see in the first year, Eliquis sold 146 million. And then it jumped to 774, and then 1860, 3343, 4872, until it became the gigantic drug it is today. And in fact, it was the 2nd biggest drug if you measure it by the full 6th year of sales, although Ozempic was probably bigger, so it's probably number 3. So again, one of the most prescribed, most used drugs in the world. Maybe not most prescribed, but certainly highest sales. So how do we figure out when is this drug going to go generic? Well, there's a lot of ways. The first way is you can just ask the company or see what they've been saying. And when you see that, you can get a really good sense for the answer.
It's like $60.
Another couple ways to do it is, so let's see what they're saying in their filing. So we're just going to open up the 10Q, and we're going to look for Eliquis. And it looks like they're still saying 2026, and they have some details here. And we're going to actually make a whole page just for this one drug. And let's see if we have it. Yeah, we got it here. And And we're gonna make a little section just for the patents. This drug ended up becoming a drug called 𝗕𝗓𝗡𝗦. Okay, so it says here that there's a 2026 patent that's a composition or matter patent. That's usually the strongest kind of patent. So we know 2026 is at least locked in. But then there's a formulation patent. Formulation patents are usually very weak and they get challenged and they get kind of turned over. So it looks like they have a settlement with some generic companies, and then they also upheld the formulation patent. So that's kind of interesting, but litigated successfully and after appeal the 2026 and 2031 patents. So that kind of clouds the picture quite a bit, because depending on the terms of the settlement, some of these settlements could allow the revenue to drop still by quite a lot. Oh, interesting. It says here that under the terms of the previously executed settlement agreements, the permitted date of launch is April 1st, 2028. So that means that April 1st, 2028 is going to be the expiry. So they did get a couple extra years. I did have it right the first time. 2028 allowed date of launch as per settlement, 2031 patent upheld. And you can see that we forecast quite a bit into the future. In tech, we forecast quarter to quarter because we don't know what that's going to happen. But in pharma, we know what's going to happen. And you can really look down the road and plan for these patent expiries. And so in this case, I think that we're going to have a little bit, in fact, I bet you it's going to start declining. There's a lot of other factor 10 inhibitors. I think it's factor 10, yeah. Factor XA, factor 10A inhibitors. I wonder if those drugs are kind of what's driving some declines. But anyway, it's more important to know when the expiry is happening than the exact amount of revenue. It's good to have both, but just knowing when the expiry is coming is half the battle in forecasting these things. Because the current revenue is going to basically be unchanged from year to year, at least on a relative basis. But when the expiry comes, that's when the revenue kind of gets squashed. So basically they're saying, that's when you can expect the generic. Now, I still want to know what's happening with the business as we speak. And I also want to know what their economics are with Pfizer, because I think that's pretty important. But if you look at the last quarter, Eliquis grew 7%. And before that, it grew 9%. Before that, it grew 7%, 2%. So it kind of looks like it's still growing. I have it shrinking, so maybe it'll still grow. And I don't know if warfarin's been completely displaced or warfarin's still used or what, but it seems like my forecast of it shrinking is probably not fair. And I can adjust that for a little bit of growth. And we basically build the forecast like this. Every drug, we just go drug by drug and kind of see what we can learn on each medicine. And we can't be super smart in every single medicine. It's going to take a lot of research to do that. We're going to try. But if we get a good sense of what the portfolio is and where things are going to go, we get closer and closer to where we need to be. It looks like Eliquis is already generic in Europe. And as you can see, most of the revenue is coming from the US. So 8.6 out of the 12.2. So what is that? I guess I have a calculator here, don't I? 8.6 out of 12.2 is 70%. So most of the revenue's in the US anyway. I'm just gonna maybe jot that down in the Eliquis section. So that's gonna be countries like China and Japan, principally, but also Europe. Oh, I guess the UK found the patent invalid. So it's basically just kind of over for Eliquis outside of the US. So it says that they jointly develop and commercialize Eliquis. It was discovered by BrIstol. Pfizer funds 50 to 60% development costs, so that's long over. Profits and losses are shared equally on a global basis, except in certain countries where Pfizer commercializes and pays BrIstol Myers. Okay, so we have some details here. This is very interesting. So they book the revenue, which is the end user revenue. Okay, it looks like they book revenue for, and this is basically an accounting question, or I can put in economics. BrIstol books US, Europe, and China, and Japan. Japan, Australia pays roughly 50%. So what's interesting about this is the margins on this product are much lower because they have to pay Pfizer. So even though it's a $12 billion revenue product, it really looks more like a $7 billion revenue product from like an actual gross profit perspective. Because if you do the math, this is like a really subtle detail, but they have $6 billion in gross profit out of 12, 206 in revenue. So it's like 50%. So gross margins are very low for this drug because of the Pfizer relationship. So I just wanted to get that clear too before we moved on. So that's kind of where Eliquis is. Over time, you learn from looking at other companies and so forth what the like rivals are. Like there's this other drug, Apixaban, and you learn about like, well, what could come out that replaces the factor Xa inhibitors? I think the factor Xa inhibitors will be around for decades. They're very, very good drugs. They're much better than warfarin, which was a medicine that's, kind of very, very old medicine. Actually comes from University of Wisconsin. That's WARF is Wisconsin Alumni Research Foundation. So warfarin was the first drug from that. With respect to somebody saying, is he going to do this for every drug? This is going to take forever. Yes, it's called hard work. Welcome to reality. I'm glad I can introduce you to it. If a drug company has 35 drugs, you got to look at 35 drugs. You can't just look at one and guess on the other 34. Maybe that's what you do. Maybe you have ADHD. I don't. Back to work. You're not going to make it in this life. You're going to make it this world. You're going to be getting my coffee. If you're lucky. This is a good job getting my coffee. And there is a lot of benefits from knowing a lot of these medicines because let's say you were a venture capitalist. Well, you have to know which drugs are big and which aren't, and what the opportunities are. Look at the huge opportunity to replace warfarin was much bigger than anybody thought. But if you were paying attention, you would have seen that. When Eliquis came out, I thought it would be a $6 billion drug. So that tells you something. It ended up being a $12 or $13 billion drug. In fact, I hired the person who was the head of commercial for Eliquis outside the US. All right, let's go back to the second biggest drug now, which is called Opdivo. Opdivo is a PD-1 inhibitor, which is called a checkpoint inhibitor. So PD-1 is, kind of like this breakthrough cancer drug. And Keytruda is their rival. And Keytruda's kind of done better, a little better than Opdivo. In fact, you can look at the sales here. Keytruda outsold Opdivo in its sixth year. And right now, Keytruda's doing like 20 billion, I want to say, which there was never a drug that sold 20 billion until now. So you can see like which ones started to break away. If you graph these, you can see that like Keytruda started to break away, even though it was neck and neck with some of these other drugs, these four, it really started to break away in year 5 and 6 and 7 to the point where it was twice as big. Let's look at Opdivo, which had a similar story. So when did Opdivo get approval? And remember, this is a biologic. It looks like 12/22/14. So right at the end of 14. I remember when this approval came out, and I remember arguing with one of my colleagues who's a chemist whether or not this would be a major medicine. And he had a hard time seeing that you could value a drug that's going to be a $5 or $10 billion seller. And one of his issues was that it was hard to give that much credit for a drug that hadn't come out yet. And I think one of the things I taught him, he's a very smart guy, so I didn't get to teach him too much. But one of the things I taught him is that, yes, sometimes you can be comfortable saying a drug will sell 5 billion or 10 billion. When Nivolumab was coming around, I said, this could be a $10 billion drug. And he was like, nah, no way, that's crazy. You can't, value that, assuming that. And I was like, well, how about, can you value it assuming 1 billion? I said, that's way undervalued. So sometimes you have to make big projections. So anyway, Opdivo ended up being a very, very big drug. In fact, it was kind of lucky because it had its first full year, but it was one of the biggest drugs ever in its first full year. Take a look at that. Isn't that crazy? It was actually outpacing a lot of these drugs, but it slowed down really fast because Keytruda kind of out-executed, and you can see it just hit a wall. And even though they were first, Keytruda just bowled these two. Keytruda kind of won the checkpoint wars. So you can kind of see BrIstol Myers starting out red hot, and then Keytruda kind of taking over rather quickly. So really unfortunate for BrIstol, kind of that they lost the PD-1 wars. And if you want a really good case study on nitty-gritty pharma, like super nuanced pharma, I would study how did Merck beat BrIstol Myers to win the PD-1 wars. They have about 65% market share. Even though BrIstol was first, they understood the mechanism a lot better. Merck was not a cancer drug company. Merck did no oncology whatsoever, no heritage in oncology. BrIstol Myers invented chemo. They literally invented chemo. They invented Taxol. And so BrIstol Myers' long heritage in cancer. They did Erbitux with Imclone. They understand cancer. They've been selling cancer drugs for years, and BrIstol Myers gets outfoxed by Merck. Merck's not like a substantially bigger company or anything, but Merck figures out how to sell this medicine way better than BrIstol. How and why is a long story I'm not going to bore you with, but it is, if you're really interested in pharma, like you work in pharma for a living, like these are the stories that matter. It's growing a tiny bit, but eventually nivolumab will go generic just like every other drug, but it won't go generic in the same way because it's a biologic. It's one of those really big molecules. It's hard to characterize. It's hard to know exactly what's going to happen to it. So, but when biosimilars come out, they have almost like a generic-like decay. So there's that. And then, like I said, let's see kind of what the company says. It doesn't hurt to ask them. BrIstol Myers is a big company. They're usually pretty honest. And back in the old days, nobody trusted them, actually. There's a good reason for that. So they're saying nivolumab patent 2028. Rest of world like 2030-ish. But most of the revenue is probably in the US. So 2028, and then the biosimilars start hitting. They're trying to do a subcutaneous formulation of nivolumab. So instead of an IV, you can use a subcutaneous. But I think that it's not going to go well. Checkpoint inhibitors have largely been kind of like well understood in terms of where they work and where they don't. So I don't see this market growing very much, although I think Merck's still growing, which is amazing. So these are kind of boring drugs, and a lot of the bigger drugs are kind of boring. There's not a whole lot of sophisticated analysis you'd have to do. It's just like, okay, what's the forecast? We'll get to some pretty exciting analysis in a second. So let's move on to Revlimid. Revlimid is an amazing drug. We can write books about Revlimid, and I think somebody should. Revlimid came from a company called Celgene, and Celgene pioneered a drug called thalidomide. Thalidomide was a drug that basically caused the creation of the FDA. Thalidomide caused birth defects. It was given to pregnant women intentionally for somnolence or something like that, or to induce somnolence, to help them sleep. And it ended up causing birth defects, and the FDA didn't approve thalidomide. These medicines save so many lives. They're so amazing, and it's important that this pharmaceutical ecosystem keeps making money because we wouldn't have these drugs otherwise. And the amount of life that's been added to the world through drugs like Opdivo and Revlimid is incredible. I have friends whose lives have been saved by Revlimid. What's interesting is there was a small royalty for Opdivo to this Japanese company, and they make a fortune from this royalty. It's very funny. But BrIstol owns almost all of Opdivo. But that little bit that goes to the Japanese company, because it's such a big drug, it actually is pretty valuable. Opdivo is actually a little bit more balanced internationally. It's like 60-40 roughly. They're still developing Opdivo pretty extensively, but I don't know that it really is even worth it. There's Ono. That's the party, by the way, that has a tiny royalty. It didn't come from Ono. It came from Medarex, old biotech company that they bought out. Just gonna write that here. Origin, Medarex. And so anyway, we have a sense for the expiry for Opdivo. Let's move to Revlimid. So I was mentioning that Revlimid is this incredible drug, and it is. Revlimid ended up becoming the marquee treatment for multiple myeloma, which is a very rare cancer. But Revlimid has gone generic, and it's in a weird decline phase because it's in a very strange circumstance. It's sort of declining very slowly. And again, BrIstol Myers bought Celgene, let's see when, 2019? I don't remember when the deal closed, but I was in jail when this deal happened, and I was analyzing it very carefully. I thought it was a good deal. In fact, some of my inmates, the people I was in jail with, they woke me up, and these are guys who are drug dealers, thugs, and they're like, "Martin, there's big news about a big drug merger. You should look at it." I was like, "What?" They said it's called Celgene or something like that. It was so funny that they knew what I was interested in, and they were like, "Hey, I saw it on the news. You should check it out." So that was really funny that that was the kind of interactions I'd have. All right, so Revlimid is sort of like in this weird slow decay, and it's going to continue to sort of decay over time. And it actually doesn't matter very much how much it decays, because it's going to decay to nothing in essence. It may stabilize, but it probably will decay to nothing. You can see almost all of the sales there in the US, almost every dollar. And so the trick with Revlimid is, like thalidomide, it causes birth defects. So they kind of like sneak through the patent system by not patenting the drug, but patenting the birth control system. And that kind of got them a little extra time and a little extra patent life than maybe they deserved. So that was a kind of a crafty move. All right, so it looks like 2026 revenue for Revlimid will really decline. They've already declined pretty substantially, as you can see. Here, the Celgene merger closed. So you don't book the revenue, the old revenue, but I think we can kind of like include the Celgene revenue, just not as a number that'll be used in the sum, but we should just put it there. But once BrIstol took over Revlimid, they got to report the revenue. And you can see it was actually a huge drug. And the Celgene deal was weird, and we are going to talk a little bit about the general philosophy of BrIstol, not just drug by drug, but BrIstol has been in a deal-making mode for the last 5 years. The Celgene deal was gigantic, and it didn't really pay off. It was just like a bizarre financial transaction where you know what Celgene was. It was just a Revlimid cash cow. And so basically they're basically just buying the Revlimid earnings and the Pomalyst earnings and just putting it in a box. So like you can see there's about 60 billion here of Revlimid and Pomalyst. Pomalyst is a lot like Revlimid, it's pomalidomide. So they basically took thalidomide, which is a super old drug, changed an atom, and they called that lenalidomide. They changed another atom, and they called that pomalidomide. And I've done that a bunch of times, and they get a new patent each time. They are slightly different drugs, but they're generally the same. But they all cause birth defects, so they have to be restricted access. And that restricted access paradoxically gives them this long patent life, which is pretty wild. So Revlimid will keep declining, I think, but it'll really fall off a cliff come 2026. So let's model it like this. Let's model it dropping 10% a year. And then starting in 2026, it really falls off a cliff. That's where in the unrestricted, January 31st, 2026, unrestricted volume from generics. Right now it's restricted volume, license. We've actually been able to look at their 3 biggest drugs in relatively short order, but now we're going to start looking at kind of some more interesting drugs that we may or may not kind of like be important. And some of these drugs are growing really rapidly, and we're gonna have to pay really close attention. If you know finance, you know that, for example, let's just zoom in really closely. If this number in 2026, instead of 1 billion, let's say it's 3 billion, and this number for 2027, instead of 200 million is 1.5 billion, and I misestimated the severity of the drop off, it actually won't matter much in the NPV. I know you finance students know what I'm talking about. Azatacam is not a big seller. These are only the biggest revenue drugs. If you know finance, you know that in the scheme of a $100 billion NPV, whether this stream is 1.2 billion in aggregate or 5 billion in aggregate, it might change the NPV by $1 billion, maybe, but it really is not going to move the needle a huge amount. Of course, these little mistakes do add up, but the big question is, will there be another Eliquis, a $10 billion drug, or something like that? That's kind of the key thing. So keep that in mind. Pomalyst, like I said, is sort of son of Revlimid, and there's a son of Pomalyst coming as well. But Pomalyst, let's see where the Pomalyst patent comes out. Pomalyst, we do not expect generic entry prior to 2026. Well, that's not good. So if generics come out in 2026, the issue is BrIstol Myers is looking at this big patent cliff. So these are kind of both 2026. And that makes sense because they both share the same kind of like intellectual property and stuff like that. So these were pretty easy to forecast. Now we're going to get into drugs that are really hard to forecast, and we got to understand them really well. Orencia is maybe the first one we'll look at, but then we'll look at Reblozyl, but also like Sprycel will be really interesting to look at. Orencia is a weird drug. It's a CTLA-4 soluble receptor. So it works like an antibody, but it's a CTLA-4. I want to look at the old revenue. Oh, I have it going way back to 2006. You can see that it was like a very slow grower. It was kind of this drug for rheumatoid arthritis that was like for people, it's like last line rheumatoid arthritis. Let's see, it was approved 2005 approval. Doesn't really matter what the exact date is, but it was approved 20 years ago, and it's still not generic or no biosimilar either. So that'll be kind of interesting to see what'll happen there. But you can see that in the scheme of things, it wasn't a huge seller, but it started to hit the so-called blockbuster status right around 2012. So that was That's when drugs like really materially large. It's often said that at big pharma, if it's not a blockbuster, you don't really care. And so Orencia was kind of a disappointment for a little while, but then it ended up kind of being a pretty big product. And you can see here that it is a fairly big product. And you can see it's kind of chugged along. Every year it's gone up a little bit. And that's what's cool about biologics, is that they can really last a long time. There's no small molecule that's lasted 20 years. So because it's hard to make, it's kind of like gets this extra intellectual property, which I know makes, different regulatory authorities mad, but haters can stay mad. And so it's kind of an amazing thing if you think about it. I mean, it's gone up every year, it looks like, without fail, right? Every single year it's gone up in revenue, 18 years in a row. And so what are people really using this for now, and why is it going up? And one thing we could do is we can look at the prescribing information, which is often colloquially called the label. Let me put in some placeholder numbers for a second, just so the numbers make sense for the annuals. And we can see that Orencia, we can put the line here. It doesn't look like it grew very much last quarter. Yeah, single digits growth, very, very slow growth for the last year or two. But at one point was double-digit growth. And so yeah, are people using this are doctors using this for rheumatoid arthritis? Are they using this for some other disease? Let's take a look at the label. And you usually just go on Orencia.com and it's there somewhere. And just off the bat, you can see it's for rheumatoid arthritis, and is that all it's for though? And what's interesting about it is it's a CTLA-4 inhibitor. We're going to talk about that mechanism a tiny bit. All these support programs so that you can make sure you get the drug. And okay, it looks like they have 3 labels: RA, polyarticular JIA, which is basically RA for kids, and psoriatic arthritis, which is basically RA with psoriasis. And so it seems like that's all that it's sort of good for. And rheumatoid arthritis is a big market, but this drug's a little inconvenient for RA. There's a lot better drugs for RA. And RA is one of the biggest markets for pharmaceuticals. You guys probably have heard of Humira, which is the biggest selling RA drug, although there are other drugs that are coming out, a lot of them from the same company, AbbVie, that compete with Orencia. So it doesn't seem like that drug will grow anymore. So the big question is, for biosimilars, for the big antibodies, it makes sense that there'll be biosimilars. But for some of the smaller drugs, it actually costs a lot of money to make a biosimilar. So there's a reason Orencia still hasn't sort of gone generic. So this goes way back when they were kind of launching it. It is an IV, which is a pain in the neck. It is a very complex drug to make, but let's sort of see if we can learn more about it. One of the things I always like to look at is dosing. Oh, they do have some more indications. Intravenous use for prophylaxis of graft-versus-host disease. That's GVHD, for anybody who doesn't know that. Maybe they just don't promote GVHD. It's not a big indication either way, but you can see GVHD as well. I thought it was good for a lot of different diseases. Sometimes a drug is good for a bunch of diseases, but not FDA approved for them. And doctors will give it anyway. Expensive drugs like this, we can look up the price of abatacept from something called Redbook, or we could just Google it and see what the right rough price is if we don't need to be too quantitative. Let's do Orencia price. Well, I also want to know the dosing. I want to say it's monthly, every 4 weeks. Okay, so it's monthly. And it looks like every infusion's around $5,000, roughly. So pretty expensive. Orencia vial price. Yeah, the price has gone up a lot since this study. This looks like an older study. Back then, a vial was $480. Now a vial is $1,500. It's around $60K a year. But if you have severe rheumatoid arthritis, pretty bad. So the question is, do people mostly use this drug once they fail a TNF inhibitor because it works through a different mechanism? And let's talk about that mechanism a little bit. CTLA-4 inhibitor, it's CTLA-4 inhibitor. And it's amazing that Google has these new quick search things. It inhibits T cells, inflammatory signal to T cells. It's a little counterintuitive, right? CTLA-4 is also called CD152. I used to know this mechanism a lot better. It's fairly complicated. So I guess it acts as a sink. It's a soluble receptor, and it'll bind to CD80 and CD86, so those molecules can't stimulate T cells. So it works for GVHD, it works for all these immune sort of specific diseases like rheumatoid arthritis. So it makes sense that it would be clinically important there. But what's interesting is they probably tried it in a bunch of other diseases and then it didn't work as well. So it's kind of interesting that some autoimmune drugs work for some diseases and not others. So it's not an inhibitor, it's really just like a fusion clone. So it is literally soluble, CTLA4 soluble receptor. So it's like increases the expression of that.